Now I'd like to turn this over to Melissa Savage, Program Manager with AASHTO, for a few opening remarks. Melissa?
To today's webinar. Today's webinar is being hosted by the AASHTO Center for Environmental Excellence. The center was established in 2001 in a partnership between AASHTO and the Federal Highway Administration. The mission of the center is to promote environmental stewardship and encourage innovative ways to streamline the transportation delivery process. The work of the center is overseen by a technical working group comprised of state DOT practitioners representing diverse backgrounds and interests, representatives from the Federal Highway Administration, as well as representatives from resource agencies like EPA and the U.S. Army Corps of Engineers. We also have staff from metropolitan planning organizations and the Association of Metropolitan Planning Organizations represented on the technical working group. The technical working group meets annually to determine the tasks that the center will undertake each year. And for the last 2 years, the technical working group has supported 2 communities of practice, one on environmental justice and this one on stormwater management. The primary goal of both of these communities of practice is to provide a gathering point for practitioners on pressing issues and a way to regularly engage through webinars, conference calls, and other online forums in order to share best practices and lessons learned. Today's webinar is the first in a series that will be conducted in the coming months, and we're also preparing a white paper on the state of the practice that will be published soon. So please feel free to head to our website, environment.transportation.org, where we will post this information, and as Scott mentioned, a copy of this webinar will also be posted there. And if we can ever answer any questions or provide additional details, please do not hesitate to reach out to us. And now I'd like to turn it over to our federal highway partner, Susan Jones. Susan?
Thank you, Melissa. Welcome and thank you for joining us to the first of this year's series of webinars brought to you by the Center for Environmental Excellence by AASHTO, Stormwater Community Practice. This forum is made up of stormwater experts from various state DOTs across the country to offer a varied viewpoint of what water quality and stormwater issues are pressing in their part of the country. Federal Highway appreciates all the hard work and expertise the group has to offer in terms of stormwater and water quality. Again, thank you so much for tuning into this exciting webinar. Now I'd like to transition back to Scott McGowan to initiate our presentation discussion. Scott is with Michael Baker International, and he will be facilitating the rest of the presentation and discussion. Scott?
Thank you, Susan and Melissa. For the next hour, you will hear from our presenters who will provide you with information on the effective, efficient, and innovative BMPs that their DOT stormwater management programs have explored and utilized. DOT stormwater programs have experienced increasing responsibilities spanning environmental and program planning, design, permitting, construction, and operations and maintenance. In this web forum, we will discuss innovative solutions that promote surface water quality protection. During the web forum, we will cover open graded friction course, its benefits, usage, and potential as a water quality treatment BMP, innovative roadside BMPs that fit within the linear transportation system, the importance of infiltration and current research to support this treatment, and winter storm management practices that will measure performance for TMDL and regulatory requirements. Our presenters are Bhaskar Joshi with the California Department of Transportation, Gianna Ratcliffe with Washington State Department of Transportation, and Nick Tiedegan with the Minnesota Department of Transportation. I will be moderating today's session. For the next hour, we will hear the presenters describe their programs and then take your questions. Each of the presentations will take about 15 to 20 minutes and will cover the topics shown here. During the presentations, please use the drop-down to select host and presenter and type your questions in the Q&A box on the lower right-hand corner of your screen as shown. We will read the questions and have our panel field them during the Q&A portion of the program, reserved as the final 30 minutes of the webinar. You can also type the questions in the Q&A box during the Q&A session, but questions will be fielded on a first-come basis, and depending on the volume, we may not have time to address all questions during the webinar. AASHTO will post a document on the Center for Environmental Excellence website following the webinar, responding to the questions we were not able to answer during the webinar. That's it for the introductory material. We'll start with the first presentation. Our first presenter is Bhaskar Joshi. Bhaskar currently works as the Chief of the Office of Stormwater Program Development at the California Department of Transportation. His office is responsible for statewide stormwater quality monitoring mandated by the Caltrans NPDES permit. His office also conducts permit-required water quality compliance assessments, BMP development, and evaluation of new stormwater treatment technologies. His work experience includes geotechnical design and construction supervision. Bhaskar has worked in the area of stormwater management for the past 12 years. Bhaskar?
Yes, good morning everyone and welcome. Good afternoon on the East Coast. Welcome to this presentation on open graded friction courses. And I hope you all will benefit with what is presented during this webinar today and our experiences in California with this BMP. So the first slide you can see now on the screen is a kind of a almost cartoon depiction of an open graded friction course, and it shows a fairly porous layer of asphalt on top of impervious pavement surface, which could be asphalt or concrete. And the way it works is when there is rainfall or runoff on the surface, it goes through the voids in the pore spaces, and then it laterally travels towards the edge of the pavement. I'm sure you all have seen great photos of, cars driving by on regular pavement and then on open graded pavement, and also experienced firsthand riding on these two types of surfaces. You can almost see nothing while, if it's a rainstorm, a heavy rainstorm, you're driving on regular pavement, you cannot see anything, and then you go onto pervious pavement, and it's a difference of day and night. So that's how normally we experience this, but there is much more going on underneath. And as you see on the next slide, we have in California been using open graded friction courses for a long time, and we have a guide, for usage guide for open graded friction course. And in fact, there are several thousand miles of open graded friction course pavement in California, and we have gone back and looked at since how long we've been using this kind of pavement. It seems starting from the 70s almost, maybe even earlier. That's what our records show. So we have this guide for a long time, and mainly, if you look at the next slide, we can look at what this guide talks about. It mostly talks about that open graded friction course is a sacrificial wearing course. It is 1 to 2 inches thick, laid upon regular pavement, and it talks about what kind of grading for aggregate, and also that it has a high void space in the compacted mix. So here we are talking about there's a distinction nowadays. There is a lot of talk about in various forums about porous pavement, and in this presentation we are talking about the open graded friction course, which is 1 to 2 inch thick layer of open graded pavement, and not the full depth pavement, which many times we talk about, which has a relatively thick, structurally competent layer of open graded pavement on a gravel reservoir. That is a different kind of situation. Here we are talking about sacrificial wearing course. So we have this guide. It talks about this pavement properties. Next, if you see on the next slide, we have a lot of discussion on what are the benefits of this kind of pavement. And you see roadway safety. It has good frictional characteristics. So your stopping distances are smaller, lower. You have high visibility during rainstorms. The contrast in pavement markings is higher during, again, during rainstorm storm periods. Drainage is improved. Surface friction, of course, is improved. And then for environmental benefits, we talk about noise reduction, a lot of talk about noise reduction. And then what about stormwater treatment? This has been a more recent phenomenon where people have been talking about, this pavement can also be deployed for improving stormwater quality. And that's where, this presentation is directed to. A lot of studies have been done, and we have had experience in California and a study which I'll talk about in later slides. As far as usage of OGFC or open-graded friction cores or open-graded asphalt pavement, as also referred to sometimes. On the next slide, please, you will see mostly this is common across various jurisdictions where OGFC or OGS is used, is for new construction, major rehabilitations, maintenance overlays, and generally where traffic volumes are high. Also, in our guidance, we have at least should be used on, in moderate to heavy rainfall areas. Obviously, there is not much advantage to using it in a desert environment. And generally, it specifies that OGFC should be used for the full width of the travelway and extend out onto the shoulder at least 1 foot, and preferably all through the shoulder. So that's the kind of usage guidance we have. The next slide also deals with some categorical statements on where to use it and where not to use it. And you see, it's preferable to use it where you have wet and nighttime accidents. You have need to improve skid resistance, and cross slopes less than 2%, and various pavement situations like bleeding pavements, or in desert areas to delay aging of the regular dense graded asphalt concrete or DGAC, and not to use it on unsound pavement or where there is spill areas where you have dripping oil or fuel from slow vehicles or stopped vehicles, which can cause damage to the asphalt, cause it to soften. Paving temperatures are restricted to less than 45 degrees Fahrenheit. And then not to use it as a surface seal. In snowy and icy areas, there have been different opinions, and we find in the literature at least, and also in some jurisdictions where it has been used successfully in snowy and icy areas, provided you don't have use of studded tires, a lot of intense use of studded tires or snowplow usage, because that can cause deterioration of the tip pavement. Also in areas of severe turning movements like ramps and or parking areas might not be a very good use. Our guidance also requires that this pervious pavement, if you want to use it on a bridge deck, it requires special approval from our structures design people. Although there is evidence in the literature that it has been used successfully on bridge decks. So that's as far as the usage guidance in our pavement, pavement section. But then we talk about, stormwater, and what we have for stormwater is a stormwater quality handbook. You can see on the next slide, you see a screenshot of our stormwater guidance design guide, which is called the PPDG Project Planning and Design Guide. And this is the guidance that we have for designing stormwater BMPs, stormwater treatment BMPs. And until recently, we did not have, this guide also lists BMPs that have been approved for use, and until recently, open graded friction course was not listed as an approved BMP. So we did a study on open graded friction courses, and I'll talk about this study just in a few slides. Generally, this guide, if we switch to the next slide, it shows, now we have OGFC in it, and it is based on a study that we did. And now it talks about OGFC as a flow-through treatment device, and that we can claim credit for stormwater treatment if we use open graded friction cores. But it has recommended uses like, you shouldn't have sediment-laden stormwater flows or impervious drainage areas, and it has a recommendation saying it should be consistent with pavement usage guidance, which I just showed you earlier a few slides back. So that it should be usage should be consistent with pavement guidance. It talks about how open graded friction cores is successful in removing pollutants, and mostly by straining and reduction in splash and spray. So there is general design guidance in this manual now, and we have open graded friction cores as an approved BMP in our guidance, and it's very valuable for us because in our current permit we are required to treat 1,650 acres of right-of-way annually, and mostly that is in TMDL watersheds, which is the total maximum daily load watersheds, and this is a very difficult target to achieve unless we have innovative BMPs like OGFC, because we have restricted right-of-way and limited, opportunities to put in structural BMPs everywhere. While this BMP is, it has multiple advantages. The approval process took a long time, to convince people that this is indeed an option that has stormwater treatment benefits. And we did a study on this open graded friction cores. I'll talk about it next. The study, if you switch to the next slide, please. The study we initiated was in 2007. It was a pilot study. And we had, we had almost 7 sites statewide. And out of those, I'll talk here about 3 of those sites along Highway 101 and Interstate 5 and California 70. Pilot study started in 2007, and the study lasted for 4 years. This is the, results of this study is what we use to get this BMP approved for as a stormwater treatment BMP. So I talk about this study in a little detail. The next slide shows you a map of where these sites were located. The small dots, red dots in the upper left corner of the map. These are the 3 sites we're going to talk about, although the sites were, there were 14 sites distributed statewide. And these sites were analyzed in detail to find out what the benefits of stormwater quality treatment benefits of this open graded friction cores would be like. On the next slide, we see some results of this study. There are 3 sites, and we have the constituents listed on the top: TSS and total phosphorus and total nitrogen. The orange bars are the regular hot mix asphalt, which is the dense graded pavement, and the green bars are the open graded friction cores, effluent quality. So the way the study was conducted is we had, sites installed at different locations, and we collected the sheet runoff from open graded and dense graded pavement. So there was a test section and a control section alongside of it, not always very close, but reasonably close. And then the runoff from these 2 sections was compared. The runoff quality was compared, and that's what is being shown here. So we can see, that there's a marked reduction in effluent concentrations of almost all constituents here, to a lesser extent nitrogen. And we also looked at metals on the next slide. I think it's metals. So the total copper and lead and zinc concentrations, the effluent concentrations at OGFC and hot mix asphalt sites. And there is a reduction in total copper and lead and zinc, except for one site, the zinc concentration is different. We also looked at dissolved copper, lead, and zinc on the next slide. That result is displayed for dissolved copper and zinc and lead. So there is for dissolved copper and lead and zinc, there is, kind of not a very clear conclusive evidence of reduction, but there is some reduction for some of the sites. But the total metals are markedly reduced. And then we looked at the summary for these same constituents. If we switch to the next slide, please. So in general, what we did is there was a reduction of in concentrations in the effluent quality. So we compared our performance of OGFC with the best BMP, approved BMP we have in our toolkit, which is the Austin sand filter, and it's listed as ASF over here. So the performance summary of open graded friction course is being compared here to the Austin sand filter. And you see the orange bar is for the sand filter, and the green bar is again for the open graded friction course. For TSS, there is not a significant difference. For phosphorus and nitrogen, there is a marked reduction. It performs better than an Austin sand filter, it looks, from the results of this study. And then on the next slide is the comparison for metals. For copper, both total and dissolved, and lead and zinc. So here we see, it performs comparable, if not better than an Austin sand filter. And based on this study, we developed some specifications, which are basically the same specifications. We don't have to do anything with the specifications. They are already in place. We have been using OGFC for a long time. And so the next slide, if you see, you'll see references to the specifications for this open graded friction course. We have standard specifications, and we anticipate the service life of this pavement to be commonly 4 to 6 years, but could last up to 10 years and as low as 2 years, which is a function of several factors, depending on where it is and what the traffic, what the kind of traffic it is taking. And there have been studies in various jurisdictions where it has been shown to last up to 10 years without maintenance. There was a study in Spain conducted on open graded friction course, and they didn't do any maintenance on it and kept on testing the permeability of the friction course until it clogged completely in 10 years. So there is evidence to show it could last up to 10 years, which is the normal rehabilitation life of the pavement surface layer anyway. And so it can serve a dual function of stormwater treatment and noise reduction and various other roadway safety aspects. So as far as the maintenance, we also looked at maintenance and rehabilitation of this kind of pavement. We already have guidance available in our maintenance manual, and that is shown on the next slide. So briefly, there are no additional maintenance requirements as far as it's the normal maintenance requirement for as far as replacement of the pavement. But For stormwater quality benefit, of course, you would need to maintain it in some way. There are various options using, either sweepers, or the vacuum sweepers, or water high pressure cleaners, or there are specialized cleaning vehicles available, which if you want to maintain the permeability over a longer period of time, that is the kind of maintenance that would be needed. But regardless, even if it is not maintained intensively, it will function as a lower permeability stormwater treatment device, and that is something that could be investigated further. In conclusion, on the next slide, we have the conclusions from this study. In general, we found that it's very effective for treating total sediment, phosphorus, copper, total copper, lead, and zinc. And if we compared it, when we compared to the Austin sand filter, there was, it's comparable or even better for nutrients and metals, total metals. Total nitrogen is not significantly different. So in the end, with this study, based on the results of this study, we followed up on getting this BMP approved. And what is now in place is on the next slide, in our, the previous one, yes. So now we have this selection matrix in our guidance. It's a BMP selection matrix, and you can see we have tiers 1, 2, and 3, and we have different categories based on infiltration or volume reduction that these BMPs provide. So there is less than 20% infiltration, 20 to 50, and 50, greater than 50%. And these BMPs are listed in tiers 1, 2, and 3. They are inside the tiers. They are not in any order of preference, but they are almost, you could pick any one of them. But tier 1 is better than 2, and 2 is better than 3. So for now, OGFC is in all the 3 tiers, regardless that OGFC does not provide an infiltration benefit or a volume reduction benefit, but it does provide treatment. So this checklist is based on treatment of our target design constituents. We have a list of constituents that we can treat for. It's feasible to treat without, without uneconomic options. And so, for example, this might be for treatment of TSS. And so OGFCs will treat TSS regardless of what the infiltration benefit is. So it is in all three categories of infiltration. So now we have this in place. It's an approved BMP, and we are in the process of looking at how to actually deploy it in a way that we can get the treatment credits that we need to get for our permit. And so that is the challenges that we are right now facing and trying to figure out, which on the next slide I've listed what kind of challenges we foresee. The first one is, the demonstration of treatment efficiency. So the regulators, they don't see this as a influent to effluent comparison. So you don't have an influent and effluent comparison as you would have in a normal BMP. What you have is a test section and a control section. The test section is your influent, and the control section, or the control section is your influent, and the test section is the effluent. So we are comparing two different sections of roadway. They might not be in very close vicinity or adjacent to one another. So that is part of the challenge in demonstrating that the efficiency of this open graded friction pavement. And then the ranking of, which I showed on the previous slide, the ranking of these BMPs, it took us a considerable amount of effort to rank OGFC, should it be on tier 1 or tier 2 or tier 3. And so this entire study, which lasted for 4 years, based on these results, we were able to rank it and place it in the selection matrix. That part is done. treatment credits. If you place OGFC somewhere in a TMDL watershed or even outside a TMDL watershed, basically you get some credit for treatment, or you claim credit, and then how do you track it? How do you mark the BMP? Where does it start and where does it end? And then if you have to maintain it or rehabilitate it, the maintenance needs to track, the division of maintenance needs to track where is this BMP we have taken credit for. And if they go in and remove it or replace it with something else, the credit has to be, reduced from our treatment credit. And so that tracking is still a matter of, debate how to do that. Who is going to do that tracking? How will we, over a longer period of time, be able to make sure that where we place OGFC is not replaced with something else, or if it is replaced, then we know that it has been replaced. So that is something we are still working out on. And then the final issue is maintenance, operations, and equipment. Is what are the kind of maintenance operations needed to keep this BMP functioning at the efficiency that we claim it to be. If it gets clogged and it's no longer functional, then we should not be taking credit for it. And to make sure that happens, do we need some specialized equipment? Is there a maintenance schedule that needs to be adhered to? And also, how do we keep on testing after installation to make sure that these BMPs are functioning as they were designed for? So that's the kind of challenges we have in front of us, although BMP is approved, and it has been proven not only in California but also in other jurisdictions that it is effective for treatment of stormwater BMPs, not just in the United States but also in Europe and other places around the world. That's the end of my presentation. Thank you very much.
Thank you, Bhaskar. Our second presenter is Jana Ratcliffe. Jana is a Stormwater and Watersheds Program Manager within the Environmental Services Office at the Washington State Department of Transportation. Jana began working for Washington State DOT in 2004 and has served as the statewide erosion control coordinator, total maximum daily load lead, and municipal stormwater permit coordinator prior to her current role. Jana is a graduate of the Evergreen State College and has a bachelor's degree in environmental studies. Jana?
Thank you, Scott. I really appreciate the opportunity to discuss some of our commonly used roadside BMPs, as well as some innovative work we're doing in hopes of improving highway stormwater management in Washington State. Stormwater runoff has been identified as a significant source of pollution in the Puget Sound and other areas of Washington State. Transportation departments across the state are required by NPDES municipal stormwater permits to manage stormwater discharges from our roads and highways. Finding effective, low-cost BMPs to manage stormwater that can be broadly applied in long, linear transportation corridors is a priority. Municipal stormwater permits in Washington State also require permittees to implement low-impact development, or LID BMPs, where feasible. LID BMPs are those that emphasize pre-disturbance hydrologic processes of infiltration, filtration, stormwater, evaporation, and transpiration. BMPs that mimic natural hydrology can contribute to groundwater recharge that feeds summer base flows, which is important for fish. Infiltration is also a proven pollutant removal mechanism, that is, if infiltration rate, soil type, etc. are within range. Infiltration BMPs also prevent surface water discharges and associated problems such as erosion and streambed scour. WashDOT's Highway Runoff Manual, which is our stormwater design document, defines minimum requirements and Department of Ecology approved BMPs that we can use to treat stormwater and provide flow control. The Highway Runoff Manual's BMP selection process, which is a series of flow charts, requires stormwater designers to evaluate the feasibility of natural infiltration type BMPs first. The following slides contain graphics from Chapter 5 of our Highway Runoff Manual. WSDOT is continuously looking for better ways to meet our permit requirements and our environmental protection goals while juggling the site constraints common to linear transportation corridors. Ideally, we want to treat large amounts of pavement within a relatively small footprint, therefore not requiring additional right-of-way. We want to improve construction and maintenance ease of access from the roadway and identify low-cost, well-performing BMPs with low maintenance requirements. Next slide, please. WSDOT commonly utilizes vegetated filter strips, or VFSs, to meet stormwater treatment requirements. VFSs are compacted roadside embankments that are hydroseeded with a standard grass seed mix. They are preferred highway BMPs because they are a simple, cost-effective means of controlling the effects of stormwater runoff from roads and highways. Studies show VFSs improve water quality by reducing pollutant concentrations. VFSs rely on filtration as the primary pollutant removal mechanism. These BMPs meet our basic runoff treatment objectives, which is an 80% removal of total suspended solids, or TSS, or they can be used as part of a treatment train to provide additional removal of phosphorus or dissolved metals. And in less urbanized areas, VFSs can generally be located on existing roadside embankments, reducing the need for additional right-of-way acquisition. Next slide. There are some limitations to VFSs, however. These BMPs are generally not suitable for steep slopes or large impervious areas that can generate high-velocity runoff. So generally speaking, they should only be used to treat smaller drainage areas. Flow must enter the BMP as sheet flow spread out over the length of the strip, generally no deeper than 1 inch. If sheet flow cannot be maintained, vegetated filter strips will not be effective. Use of VFSs can be impracticable in watersheds where open land is scarce or expensive. Also, improper grading can render this BMP ineffective. And grass density is really important since filtering through thick stands of grass is the unit function of this BMP. Next slide, please. WSDOT also commonly uses compost-amended vegetated filter strips, or CAVs, which is a variation of the basic vegetated filter strip. Compost soil amendments are added to improve infiltration characteristics, increase surface roughness, and improve plant sustainability. A typical cross-section of a CAVs includes a 3-inch layer of compost tilled into 8 or 9 inches of existing soil. The resulting embankment is not compacted in an effort to promote infiltration of stormwater into the underlying soils. CAVs meets our basic and enhanced runoff treatment objectives. So again, basic is that 80% removal of TSS, and enhanced runoff treatment is the removal of dissolved metals. These BMPs can be used to meet oil control requirements in eastern Washington as well, which is based on a high average daily traffic trigger. Next slide, please. However, there are also some limitations to CAVs as well. So an increased design time and cost over the basic vegetated filter strip is one of the limitations. We need to know the infiltration rate of the underlying soils, and therefore a geotechnical report describing the characteristics of the soils is necessary before we site a BMP. Tilling the compost can also create a soft surface initially, which can result in rutting and potential safety issues for run-off-the-road vehicles. And while CAVs provides performance improvements over the basic vegetated filter strip design, construction is more expensive and installation is not feasible in many situations, especially in urbanized environments. So typically, installation requires heavy equipment to incorporate the compost into the top layer of the soil. In areas where access and space are limited or slopes are too steep, cabs are not a viable option. And another limitation is that we don't generally use compost if we are discharging to a phosphorus-impaired water body. Next slide, please. So in 2012, WSDOT initiated a monitoring study to test an alternative to the vegetated filter strip and compost-amended vegetated filter strip designs. The modified vegetated filter strip, or compost blanket VFS, includes a 3-inch compost blanket applied to the surface of compacted soil rather than tilling in the compost. Compared to other compost-amended highway BMPs, the potential advantages of our experimental compost blanket VFS include reduced cost for construction because compost blanket applications require minimal ground disturbance, fewer traffic impacts, and less traffic control. Compost blankets may be applied over broader areas and earlier in the construction process as erosion control. Compost blanket VFSs may be an effective and cheap way to retrofit existing slopes to provide stormwater treatment to untreated runoff. And compost blanket VFSs provide a safer alternative to other compost-amended BMPs because compost is not tilled into the top layer of the soil. The embankment underlying the compost remains compacted. WSDOT will complete the monitoring study in 2018 and will provide data to the Department of Ecology to be evaluated through the Technology Assessment Protocol Ecology, or TAPE program, for approval. If approved, the BMP will be included in the Highway Runoff Manual for standard use on WSDOT projects. Next slide, please. Another BMP WSDOT commonly uses, especially in western Washington, is the media filter drain, previously referred to in Washington as the ecology embankment. This BMP can be sited on highway side slopes and medians and can be used where available right-of-way is limited, where sheet flow from the highway surface is feasible, and where slopes are generally less than 4:1. You can also use the media filter drain in an end-of-pipe application where surface runoff is collected and conveyed to a location where flows can be redispersed to the media filter drain. Media filter drains are designed with metals removal in mind. We needed a linear BMP that could remove dissolved metals where we discharge to receiving waters with Endangered Species Act listed salmon. Media filter drains are approved for basic, enhanced, and phosphorus treatment. However, phosphorus treatment only when we do not include the 3-inch compost blanket. There are 7 types of media filter drains in the Highway Runoff Manual, so it is a very versatile BMP that can be used in well-draining soils by utilizing infiltration in the bottom trench, as well as in tight soils utilizing a French drain in the bottom trench. Next slide, please. In general, stormwater runoff is conveyed to the media filter drain via sheet flow or is redispersed to a vegetation-free gravel zone to ensure dispersion and provide some pollutant trapping. Next, a grass strip provides pretreatment, further enhancing filtration and extending the life of the system. The runoff is then filtered through a bed of media filter drain mix, which is a mixture of crushed rock, dolomite, gypsum, and perlite. The dolomite and gypsum add alkalinity and ion exchange capacity to promote the precipitation and exchange of heavy metals, and the perlite improves moisture retention to promote the formation of biomass within the media filter drain mix. The combination of physical filtering, precipitation, ion exchange, and biofiltration enhances the water treatment capacity of the mix. Treated water then drains away from the media filter drain mix bed into a downstream conveyance system. Geotextile lines the underside of the media filter drain mix bed and the under drain pipe and trench if applicable. Media filter drain types 1 through 3 in the highway runoff manual are sheet flow applications with or without under drains. Next slide, please. Types 1 and 3 are ideal along highway side slopes when adjacent to a wetland and in narrow right-of-way locations. Media filter drain type 2 is ideal in highway medians, roadside drainage ditches, or other linear depressions. Next slide. Types 4 and 5 are end-of-the-pipe applications where water is redispersed to the media filter drain with or without an under drain. Media filter drain types 6 and 7 are end-of-the-pipe applications that is downstream of a detention BMP. These don't have the no vegetation zone or grass strip because of the sediment storage in the upstream detention BMP. Next slide. Types 4 and 5 are ideal where stormwater needs to be or is captured and conveyed, which provides maximum flexibility for placement where sheet flow off the edge of pavement is not feasible. Type 6 and 7 are ideal where stormwater needs to be collected and conveyed for both runoff treatment and flow control, since this media filter drain is downstream of a detention BMP. Next slide. Media filter drains also have some limitations, however, such as shallow groundwater can compromise performance if the mixed bed and under drain become saturated, need to avoid backwater effects, and lack of sufficient hydraulic gradient due to pooling at the discharge location. Unstable slopes may be problematic as well, and you may need to consult a geotechnical engineer to find out if a media filter drain can be sited in a certain location due to unstable slopes. Also, to ensure proper function, there are maximum side and longitudinal slope requirements listed in the Highway Runoff Manual that should be considered. And in areas with narrow roadway shoulders, typically a width less than 10 feet, we've found that media filter drains should be constructed farther down the embankment slope to reduce rutting and decrease overall maintenance repairs due to cars traveling off the road onto the BMP. Next slide. So the final topic I wanted to discuss today relates to infiltration and water losses on roadway embankments. The current assumption is that all water coming off the edge of pavement needs to be considered when sizing stormwater BMPs. We consider no reduction in flow or volume as water moves from the edge of pavement over an embankment, through a roadway ditch, and to a stormwater BMP. There are probably some losses and partial infiltration that does occur, but we just don't have a good method of proving what those losses are. WSDOT is currently working to develop an accurate and cost-effective method for estimating saturated hydraulic conductivity, or KSAT rates, and water losses on highway embankments. If KSAT is underestimated, dispersion and LID BMPs are over-designed, which can increase project costs due to unnecessary expansion of the BMP footprint. We are collecting hydrology data, continuous precipitation and flow, at 2 sites along State Route 12 in western Washington. Our monitoring will characterize the infiltration and hydrologic treatment that occurs along the highway embankments. Field testing will also help us validate a laboratory-derived, optimized method for estimating KSAT in compacted embankment soils. We hope the end product will be a module or land cover in a stormwater hydrologic model for designers to use to more accurately and cost-effectively model water losses over land due to infiltration. We are just beginning the embankment monitoring study, so a report will not be available until 2020. So that concludes my presentation. Please feel free to contact me if you would like more information on this study or any of the other roadside BMPs I've discussed today. Thank you for your time.
Thank you, Jana. Our final presenter is Nick Tiedegan. Nick has been with the Minnesota Department of Transportation for 27 years. His duties include facilitation of Minnesota DOT compliance with numerous water and wetland requirements and ensuring that project and environmental documents are satisfactorily developed. This includes preparation of complete guidance and training. Nick also represents Minnesota DOT on policy and stakeholder groups, including working with regulatory agencies to develop streamlined approval processes. Nick?
Hi, Scott. Good afternoon to all of you. My presentation today is winter storm management, and winter storm management is probably a lot different in the northern tier and the mountain states than in the southern states, but so the southern states will probably learn quite a bit, and the northern states probably do a lot of the things that I'll be talking about today already. So in the past, we've traditionally managed winter storms. Next slide, please. Through conventional methods such as plowing and sanding, and then back in, I think, probably around the 70s, we started to switch over to using more chemicals. Salt, sodium chloride is the most common chemical used. It's abundant, it's cost effective, and it does a pretty good job. I believe Maryland started using salt back in the 30s, so they have a lot more experience with salt use than we do. The reason I mentioned salt is because that's the water quality component that we'll be focusing on here today. So in our winter storm fighting activities, our goals are obviously public safety, get the roads clear so the public can travel in a safe manner, be cost effective. I mentioned that salt is the most cost effective chemical we have. Other chemicals might do a better job in certain instances, but they also tend to cost a lot more. And then the environment. Recently, chloride has become an issue, and so we've established some goals, next slide please, to address chloride. And we have a chloride reduction goal that's come out of a recent sustainability report that MnDOT put together, and it focuses on reducing the amount of or preventing road salt from entering lakes and streams by efficient and effective methods of snow and ice control. And we rely on the 4 R's here: use the right material in the right amount at the right time and in the right place. Every year we have our annual report, and this looks at costs, again, cost effectiveness, how we're achieving our performance, getting the bare lanes done, are we meeting our goals there, and then also how much material we use. Here we use quite a bit of salt, and that's the implication for the environment. Sand also has implications for the environment, but again, we're focusing on the salt and the chloride today. So we'd like to compare things from year to year and over time and see how we're doing. And in this case, in the previous season, we had about 53 inches of snow. The past season, about 54, so about the same. But it looks like we used about 50,000 more tons of the salt than the previous year. Well, why is that when snowfall is about the same? Well, the reason is that, next slide please, snowfall isn't really the best measure to estimate the way you're going to manage your salt and plowing and sanding measures. We use a winter severity index to look at a variety of factors like wind speed, precipitation type, duration amount, the road temperature, is there blowing snow, air temperature, dew point, a whole variety of factors. And this is a much better measure of how we do our winter management than just relying on a snowfall number. Next slide, please. And so we use these indexes to compare with how we're meeting our barreling targets and how much sand and salt we're using over the years. Next, please. So we have a variety of best management practices that we use, and I think we could probably lump these into equipment, materials, practices, and knowledge, and we'll just run through quickly a few of those right now. Training, that's kind of a basic element for anything we do. We have to show our operators how to operate the equipment, how to calibrate the equipment, how to apply the materials. So we have a range of training, and I think that's, again, fairly common with many states. And some of our chemical application rates were developed back in the 2000s. These are 2005, and primarily the chemical method and rate is was based on pavement temperature and weather conditions, whether it's snow or freezing rain or whatever. And we're certainly updating these as that's 13 years old as of now. So some other methods that we use are we cover our salt piles. All of our facilities have covered storage. That certainly eliminates the contact or reduces the contact between precipitation and the chemical, and keeps it from entering waters. We make sure that our equipment is calibrated. That way we know how much material we're using, and we can make sure that the operator, when he says he wants to apply a certain amount, that's the amount that's going out, and then we can track that at the end of the route run, and also at the end of the year, so that we know how much we're actually using. Some of the equipment upgrades, we've got a lot of plow and blade innovations over the years. Here we've got a front plow, a wing plow, and a pull behind plow. These are used for different activities, and actually it's all snow moving activities, but for different situations, and we also utilize the flexible blades, which help the blade conform to the pavement, better removal of the snow through mechanical methods. We've gone to a lot of liquid methods recently, and so we've upgraded all of our trucks to, not all of them, but most of them, to have a brine tank. And the brine tank is a salt solution, a wetted salt solution that we add to the granular dry salt. And so when before the granular dry salt gets shot off the spinner here, there's a little tube there. I don't know if you can see it on the left above the orange and white marker. So we add the salt brine to it, and the brine helps the salt stick to the pavement better, so it's not bouncing off. Another liquid practice we use is anti-icing. Before the storm comes, we go out and apply this brine to the pavement. This helps prevent the ice from bonding to the pavement, so it makes the removal easier, and therefore we have to use less chemicals at the end of the day. We use a variety of chemicals. This is just a list of some of the brine additives. They help with to inhibit corrosion, and they also help the materials, the salt, stick to the pavement. Here we've got a beet product and a liquid corn syrup product, carbohydrates, real sticky, and they can help the material stick to the roadway. We also use other chemicals such as magnesium chloride in very specialized situations. We have some non-chloride chemicals in the next slide. Potassium acetate we use on our fixed bridge de-icing locations, and we're also looking at using potassium acetate on our route now. So we're looking at some of the non-chloride chemicals. We're going to get into some passive measures. Right now, blowing snow control, nobody wants to drive through that, unless, of course, maybe on a snowmobile. But next slide. We use some tools to reduce that blowing snow. We use living snow fences, which is on the left. You can see this row of, I believe that's corn. Try to have a minimum of 6 rows of corn left in place. We work with landowners to compensate them to make these things available. And we also build structural snow fences on the right. Next, please. We also do some earthwork to help control where the snow is going to be trapped at. Instead of trapping it out in the middle of the highway, we can now trap it in the ditch a little bit better. And then also things like the hardware in the right-of-way also can affect where the snow ends up. The next slide is a comparison before the living snow fence was installed on the left, and after the winter snow fence, living snow fence was installed on the right, and you can see a tremendous difference. And what that means is that we don't have to apply as much chemical in this section of roadway where we have this living snow fence. So that's certainly a benefit. Now we get into the weather technology, some really cool stuff here. We have a road weather information system, as do many other states. We have, I believe, 97 sites around the state that measures a variety of parameters: air, wind, precip, pavement, subsurface temperatures, all things that now go into our recommendations for how we manage our trucks, our plow trucks. Next, please. There's kind of the grid of the 97 stations we have across the state. Not only do we have fixed stations, but we also have mobile stations. Most of our trucks now are equipped with pavement sensors and other information that can be used along with the driver's observations as to what's going on. So we have fixed and remote weather stations all around the state. So how this works is that we can use the information from the fixed and mobile weather stations. We transmit that information to a central processing center where recommendations are developed as to how to optimally manage that section of roadway, and with respect to chloride, how much chemical we need to apply in that area. Much more refined than the charts that we saw earlier, which was one sort of number or range of numbers. This is a more precise and hopefully accurate way to recommend the amount of chemical that we're going to apply. We think this is a really good way to help reduce the amount of salt and chloride that we're putting down. So much so that as part of our sustainability goals, we've set a target for salt use based on the MDSS, I should have probably spelled that out, the Management Decision Support System target. And so once that recommendation comes in, we would like, this is a 5-year target now, we'd like to be less than 10% above that MDSS recommendation. We also have really innovative people out in the field, and they've come up with some interesting innovations as well. Here's a slurry truck they've developed. It applies a slurry in a precise location, and they actually have a patent on the auger. Next slide, please. This is a plow that looks like 2 plows welded together. Our district folks felt that that was a better way to get the material off the roadway, and so these things are developed in our field shops, our truck stations, and they're used. The slurry truck, I think now they're using it on 36 of the trucks in that area. So next slide, please. Also, there's a lot of research that goes on with respect to winter operations and chlorides in salt. Clear Roads, the multi-state effort to find ways to best manage our operations. MnDOT does some of our own research. We've also partnered with our local road research board, which is our county and city partners to do research. And then the NCHRP, there's some chloride-based efforts that have been done there, and I think right now Henry Barbaro and myself are putting together another proposal that might get considered for that, so keep an eye out for that if you're interested in this. Then we also have information for the traveling public. I believe many states have these sorts of things, cameras and road conditions. And in this situation here, it looks like we've got a storm coming in southwestern Minnesota because the traffic speeds are way down. So let's move forward here. So at these weather stations, we also have a camera, and the camera can be accessed by the public through our 511 site and show the conditions at a specific location. Next, please. We can also track our plow cams, and the public can actually ride along, see where the plow cams are deployed, see where a particular plow is, and then see what the conditions in that plow are. Next, please. And that sounds all fine and good, but what happens here in Minnesota is our state regulator, the Pollution Control Agency, has found that they've declared that several of the waters in the state, many of the waters, are impaired due to chlorides. And so, next slide, please. They've developed TMDLs, total maximum daily loads, which is a regulatory mechanism, and then also chloride management plan for the non-regulated activities. And in the Twin Cities Metro, 23 lakes, ponds, and wetlands and 15 streams have been identified and are currently under TMDLs, and so there are waste load allocations associated with that. Next, please. We and our local partners were at the table when the TMDL was being developed, and so the outcome of that was, rather than relying on an equation that has a numerical number that's typical of the waste load allocations in the normal TMDLs, this TMDL has a performance-based approach where there's an emphasis on minimizing the use of salt and improving the winter maintenance practices. There's also going to be a statewide chloride plan that will be similar to the Metro plans. But as part of this next slide, the PCA developed a tool so that the winter maintenance operators can check to see how well they're doing. And this is a series of about 180 BMPs in a question and answer form. And so if you provide an answer such as, are you calibrating your equipment? Yes, we do it all the time. You get a green score, or no, we don't do it ever. You get a red score, and you can evaluate your performance. And then you can use this tool to help account for how you're performing when the TMDL requirements go into the MS4 permit. And so at MnDOT, because we have helped develop this tool with the PCA and are using many of these same practices, we think we're well positioned to do well when it comes to assessing our operations for compliance with the MS4 permit. Next, please. The TMDLs are based on surface water impacts, but there's been a growing concern also on drinking water aspects, including groundwater. And there was a good webinar in March that Maryland DOT and New Hampshire DOT participated in, and they talked about how some of the things they're doing to work with their regulators on drinking water aspects associated with winter maintenance. Next, please. So while we have a variety of tools to work with out there to manage winter storms and to reduce chlorides, we still have some gaps. Next. And so Minnesota, MnDOT, as part of our salt sustainability program, is continuing our efforts to advance our knowledge As part of our program, we've hired a consultant to do a literature search worldwide of salt reduction strategies, put together a list of BMPs that other folks are doing out there, put together new training materials and guides, develop an annual salt reduction measurement tool, and basically we're going to keep working with others to figure out ways to continue to reduce our salt usage, because salt, once it's in the environment, is going to stay there. There's no good way that we know of right now to treat it, so we have to keep learning better ways to keep our to manage our salt use. That's it. Thank you.
Thanks, Nick. This concludes our presentations. We would now like to hear from you for questions and answers. Please type your questions in the Q&A box as shown on this slide. We will answer them on a first-come, first-term basis as time permits. Now we'd like to begin our response to questions you have submitted and discussions on the topic. First question. This one's for Bhaskar. On the research, are you distinguishing between open graded friction course, OGFC, and permeable friction course, PFC?
This is Bhaskar. I don't know what the question intends, but I think we are not distinguishing between the two unless there is some specific difference that the questioner has in mind.
I think it might be that the open graded friction course is a Caltrans terminology.
Yes, that's true. Yeah, it is a different terminology is used in different places, like open graded asphalt, concrete, open graded friction course, and maybe permeable friction course. The main thing is that this is a wearing course 1 to 2 inches thick that is used on dense graded pavement or concrete pavement. That is, if that's the case, we are talking about the same thing.
Okay, great. Thank you, Bhaskar. Next question is for Nick. What is your criteria for applying salt versus sand? Does sand have a phosphorus problem?
We generally don't use a lot of sand. Sand is we use the chemical to help lower the freezing point of the water, so it makes it melts the snow and ice, so to speak, in a very general way. The sand is more used as an abrasive for traction, so they have very different uses. And the sand would be used more in a colder weather situation where the salt becomes less effective.
Thank you, Nick. The next question is for Jana. Is the vegetated filter strip necessary for pre-treatment for the media filter drain, or would the media filter drain perform without the vegetated strip, specifically in an arid area?
Thank you for the question. Vegetated filter strips can be used on their own and do not have to be tied with a media filter drain. Each of those BMPs is kind of its unique own BMP. There are a lot of options kind of described in the Highway Runoff Manual. Chapter 5 goes into great detail about each of the BMPs, and you can go to the first page of each BMP and see kind of a high-level summary of the function, the effective life, cost, O&M, and then you can dig into the more specific design requirements and kind of design drawings and things like that. But they are unique BMPs and don't have to be paired.
Thank you. Another question for Jana. What is your go-to BMP? The BMP that you use in the majority of the state, and why?
Ooh, that's a really good question. I think it depends on whether it's Eastern Washington versus Western Washington. So we have very different climates on each side of the Cascade Mountains. Western Washington is very continuously rainy with low-intensity storms, mild climate, whereas Eastern Washington has kind of those more intense storms, more severe climate, both hot and cold. So the tools that we use vary depending on whether you're on the east side versus the west side. Also, soil type and infiltration is very different, which is a kind of a key indicator of which type of BMP is going to work best. I think generally speaking, in Western Washington, we tend to gravitate toward the compost amended vegetated filter strips and media filter drains, whereas in Eastern Washington, we use more of the infiltration biofiltration type BMPs.
Thank you, Jana. The next question is for Bhaskar. How did the open graded fiction course's water quality performance change over time, as in year after year?
Oh, that's a very good question. Our study lasted for 4 years, 2007 to 11, and we did see some decline in the permeability specifically of the pavements, and but we did not look for a trend because it's not a sufficient period of time compared to the total life of the pavement to really find out if there is a significant decline in the performance. So what I showed you was the average effluent quality in those graphs or bar charts, and there was an analysis done for. We did some analysis on the confidence levels we had for these constituents, and those confidence levels, 90% confidence levels, were calculated, and they were, there was not a large spread for those few years of data that we had collected. I don't know if that satisfies, is a satisfactory answer.
Yes, thank you, Bhaskar.
Yeah.
Next question is for Nick. How close are you to meeting your maintenance decision support system based chloride use goal?
Thanks. The goal is to be within 10% of the MDSS recommendations within a 5-year period. We've only been measuring for a couple of years now, and I think I think the last year we were about 18% over, so pretty good, but still have a ways to go to meet that goal.
Thank you, Nick. The next question is for Jana. What is the difference between basic and enhanced treatment?
So basic treatment is based on a performance goal of meeting 80% removal of total suspended solids, and enhanced treatment has a performance goal of providing a higher rate of removal of dissolved metals than basic treatment facilities, and that has kind of a influent concentration range associated with it, but really we're looking at dissolved copper and dissolved zinc removal efficiencies with enhanced treatment.
Thank you, Jana. The next question is for Bhaskar. How has open graded friction course held up in areas with significant winter snow and or icing?
None of our sites were located in winter or snow areas, and so I don't think we have a lot of experience with usage in winter and snow areas, but based on what is out there in the literature, it seems it has been successfully deployed. And even Massachusetts, they're looking at deploying it as a stormwater BMP. So I think there are instances, or at least there are experience in other jurisdictions of successful deployment.
Thank you, Bhaskar. The next question is for Jana. Are there any limitations to the modified vegetated filter strips?
So we're pretty early on in this new design, so it is not even an approved BMP for use yet by our Department of Ecology, so that is a huge limitation. We need to collect data on its performance, whether it meets basic treatment and or enhanced treatment, and then submit that information to Department of Ecology so they can hopefully approve it as both basic and enhanced treatment. Also, the other limitation that we foresee with the modified vegetated filter strip is that we don't typically use compost when there's a phosphorus impaired water body. So that will be another thing that we'll need to consider when using that BMP.
Thank you, Jana. Next question is for Nick. Do all of your plow trucks have the maintenance decision support system / automated vehicle location?
Right now, about 630 of our approximate 800 trucks have the MDSS AVL on them.
Thank you, Nick. Next question is for Jana, I believe. The question is, I believe that you mentioned that you do not compact the areas that you incorporate compost. Do you have information on effect on car runoff incidences? How does it affect those events? Do you have any recorded information in relation to safety?
So that's a great question. We have seen an increased maintenance issue when it comes to BMPs that have the loose embankment. I don't know that we have specific safety concerns or data showing that there's been significant accidents or anything serious that has occurred based on those soft shoulder areas, but it is definitely a concern that we've identified, and it's something that we are trying to address by, first of all, looking at the blanket option, so just putting the compost on top of the compacted shoulder so that we're not creating that squishy area. And then also, where possible, like with the media filter drain, putting some grass on top of the media bed so that you get that the roots to kind of harden up that area as well. So we are looking at some other options to try to avoid the soft areas.
Thank you, Jana. I have one more question for Bhaskar. How successful have you been in convincing your regulators the concept behind open graded friction course?
Oh, very, very good question. That conversation is ongoing as of this time. It seems there is, we have a state board and we have 9 regional boards. So even though there are folks in the state board, the regulatory board that are favorable towards the use of this as a treatment BMP, there may be others in regional jurisdictions who are not as convinced, and we will have to present the results of our studies and also examples from other jurisdictions to justify the use of this treatment BMP for crediting purposes. So even though, and the main issue has been to show how it is, how open graded friction cores is beneficial for stormwater treatment, because we are not able to, we almost need another, study which has a side-by-side comparison or a before and after comparison. That might help, and we are, presently in conversation with our regulators about this issue. But it seems the evidence is fairly convincing. All we need to do is to, present it in a manner that they accept our conclusions, or they are comfortable with our conclusions. There is no doubt that, this is an effective treatment option, and not only effective, it is cost effective. Wherever there are limited right-of-ways and you don't need drainage improvements or alterations, all that kind of benefits.
Thank you, Bhaskar. That's the end of our Q&A session. So I would just like to say that this concludes the Stormwater Community of Practice Web Forum. I'd like to thank AASHTO, FHWA, our three presenters, and all the attendees. As noted earlier, a recording of this presentation will be available and posted on the Center of Excellence website. We will also be posting a record of the questions and answers. Thank you all for attending.